Good morning, good afternoon, or good evening, everyone, wherever you are in the world. Thank you for joining us today. It's our pleasure to welcome you to the very first edition of the October Safety Series. For those who may not know me, my name is Sela Gebermeden, and I serve as the FIA Sport Club's Development Project Manager. I'm responsible for overseeing the FIA Sports webinar, and I'll be supporting our presenter throughout today's session. We are kicking off this series with a webinar focused on data-driven safety improvement. Our speaker brings extensive experience in this area, and I'm confident you'll be finding today's session both informative and valuable. Before we begin, just a few quick housekeeping notes. Please make sure your microphone stays muted throughout the session to help minimize background noise. And if you run into any audio issues, we recommend trying a different device or rejoining the webinar. To ask questions, some of you already know the drill. Use the Q&A function located at the bottom of your screen, and you are welcome to submit your questions at any time, and we will address those during the Q&A segment at the end of the webinar. Of course, today's session is being recorded like all our webinars, and we encourage you to be on the lookout for that as we will be sharing the presentation and the videos on FIA Networks a few days after the webinar. Now, allow me to introduce our speaker for today's webinar. We have today Marco Petrilli, Deputy Safety Director and Head of Research and Vehicle Safety at the FIA. Most of you know he plays a pivotal role in the FIA Safety Department, focusing on the development and implementation of safety regulations across various motorsport disciplines. He has been especially influential in improving safety in the World Rally Championship, where he has been instrumental in advancing safety measures. So now I'll hand it over to Marco, wishing everyone a great session.
For the introduction. Good morning, good afternoon, and good evening to everybody. Again, I'm Marco Petrilli, working as a Deputy Safety Director and Head of the Research and Vehicle Safety. Just a bit of additional information about my background. Joined the FIA beginning of 2018, mechanical engineer, Italian. I think you can get it from the accent quite easily. Worked in F1 with the current Racing Bull Formula 1 team for 6 years. Then I moved to Germany, working for Hyundai Motorsport, mainly for the WRC and the customer project to TCR and ready to cars. So today, starting with the presentation. Table of content. I'm going to give you a bit an overview about the October Safety Series and webinars that the department is gonna present. Are gonna be 4, each of them. This one is gonna be the start, so they're gonna cover the 4 weeks of October. I will give you a quick overview about the technical and safety department. So giving you information about how it is structured, the scope of each single group, and the main target clearly of the department. I will mainly discuss about accident investigation, the importance of this task for us, and I will bring you to case studies. The accident in F1 during the Silverstone event in 2022, and the accident of Neville during the Rally Chile in 2019. We will close the session with information about our WADB platform and additional information anyway about how you are anyway a great support for us and how we are always keen and we need of your support when we talk about improving safety in motorsport. So, as previously introduced, in October we have organized 4 different webinars. So today we are gonna start with the data-driven safety improvement that I'm gonna present. Next week we will cover all the aspects related to the safety equipment homologation process. 22nd of October, we will talk about the circuit homologation process, and we will close this series 29th of October with the closed road safety session. So, technical and safety department. So we are talking about a department of, I would say, over 80 people. It consists of mainly of 2 pillars, and the technical side, where we have the regulation and control group that mainly consists of all the people taking care of the different FIA championship, and the cross-disciplinary expertise. It consists of basically groups that are collaborating transversally on all the categories. So electronic department, power unit, and performance simulation. In terms of safety, we have 3 main pillars: operational safety, safety equipment and homologation, and the research and vehicle safety. So focusing more on the safety side, and starting from operational safety. So this group is mainly in charge of performing all the different studies related to the definition of a circuit in terms of analysis and in terms of information. So linking as well to the name of this seminar, so the data-driven. Each single circuit is analyzed, so is basically simulated, considering anyway the performance of the car that is gonna compete, and the homologation and license that is gonna be requested for it, in terms clearly of performance and in terms of weight. And each single simulation and project is basically analyzed internally in order to define all the different safety aspects. So definition of runoff area, definition of the layout, clearly definition of the first and second line of protection. So where to install a tire barrier rather than a tech pro. And so on. So everything is analyzed within this group and is basically defined following a quite deep analysis of the project. Then we have operational safety and medical and rescue, and let's say these main tasks are linked to the definition of all the operational aspect of an event on circuit and in closed road. Safety equipment and homologation. It is mainly in charge and responsible for all the monitoring and deployment of the different safety standards. As you know, we have several standards that cover the specification of most of the competitor equipment parts, but as well on the circuit side. So this group is mainly in charge of deploying the standard, monitor that all of them are respected, and as well the main link between the FIA and all the relevant manufacturers. Then to conclude the description of the department, we have the research and vehicle safety that I'm the responsible and head of this group. it is mainly in charge is, let's say, the research body of the department. So we basically collaborate with all the different groups within the technical department, within the technical group and safety group for all what regards the engineering study that may lead to the definition of a new standard, the definition of all the different technical regulation on a clearly safety point of view. And as well, we are in charge of all the part related to the crash investigation. That is, I will try to give you additional information in this webinar. One of the main tasks of the department. So, target of the safety department, safety and technical department, is mainly to ensure that driver, official, media, and spectators can attend and compete in motorsport in, let's say, a safety environment. How we try to achieve it? Clearly with all the aspects related to the safety regulation. When we talk about safety regulation, I'm not just referring to the technical regulation related to the definition of the car and of the car itself, but as well to all the aspects related to safety that we can find in the sporting regulation and in all the different documents that at the end regulate a competition. Clearly, with the research and development, the department invests anyway continuously effort and resources in order to monitor what happened in the motorsport world and try to investigate in which area we can work in order anyway to always evolve and always try to improve the safety in motorsport. As well, we work a lot on the training and awareness. So we are always, let's say, proactive in try to share what is the best practice of the different standards and as well of the different regulation with competitors, anyway, as well with spectators when we talk about location, for example, of fans in a closed road event, in order to be sure that everybody is aware of the best practice that needs to be, let's say, followed in a motorsport environment. As well, we are always in collaboration with aspect. Technical safety department is not, let's say, a closed box. Most of all our projects are performed in collaboration with what we can define aspect. Clearly, when we talk about definition of technical regulation, we are all the decisions that we take are never, let's say, just coming from the FIA. It is always a discussion, peer review, and agreement with the, let's say, relevant stakeholders. So again, if we talk about technical regulation, manufacturers are always involved in the discussion. When we talk about, for example, an helmet standard, on the other side, we have always all the helmet manufacturers, because clearly, in relation to the project, we need always to engage and collaborate with who we think is the worldwide aspect in the specific topic. So, accident investigation, as I said before, is really one of our main tasks within the safety department. Why we think that the accident investigation is crucial when we talk about safety? It is, let's say, the main tool that we have in order to check that what we are deploying is actually working. So it is mainly for monitoring and evaluating that, first of all, the technical regulation of the car or the helmet that the driver is using or the sporting regulation that is covering that competition is anyway working. So if we have an accident and we see that everything works, there is a positive outcome for us. But as well, we need always to check and monitor that what we deployed is as well correctly used in motorsport. As well, accident investigation on the other side allow us to understand if in a specific condition we may observe what we can define as a safety weakness, and in relation to it, clearly trigger a new research in order to cover it. And this one is, I think, let's say the main outcome of a crash investigation. So understand what happened, understand that something could have been avoided, and react in that respect. Then clearly, just to give you some number, then we will cover it. In the last 5 years, we did perform approximately 750 crash investigations. So clearly, have always a control of what happened on track, allow us as well to define trends. What is a trend? I will give you an example. If analyzing the rally competition, what we can see is clearly that the highest percentage of impact that may experience and may result anyway in a bad outcome that can be clearly an injury for the driver is a side impact. So clearly, when we talk about medium long term, and we are able to build a strong background of what happened on track, we are as well able to spot which are the trends. So which are the main safety weakness in a specific category or in a specific condition, and clearly be able to see the resources and focus more on that specific accident. Then clearly, it is not just a matter of car specification or improve the car. It is as well a matter always to monitor what happened on track before or during an accident. So as well, it allows us to investigate how we can share more our best practice via training and education. So moving on and talking really about what we do when we perform a crash investigation. So basically, just giving a bit additional information about what we do here in Geneva. Every single Monday, most of the time after lunch, we have an internal meeting where we analyze all the accidents that we have observed in motorsport, not just in FIA competition, but as well in international and national series. When we analyze an accident, we mainly focus on 4 different aspects. The first one is clearly related to the car response. So how the car, let's say, responded during a crash. clearly in terms of deformation, but not only. For example, we try to understand why the accident happened. So what caused for example, the lose of control. As well, we try to understand better and mainly what was the energy management of the car. On top of the car, clearly we focus on the competitor safety equipment. So we try to understand here, clearly the picture is quite self-explanatory. If the driver, for example, did experience an impact within the cockpit, that could have led to a, let's say, impact with one of the competitor safety equipment. Then clearly we investigate the environment. So in terms of circuit and closed road, how the, let's say, infrastructure worked. And then as well, we focus on all the operational aspects. So car response. When we talk about car response, clearly from our side, what is fundamental to understand and to investigate is the dynamic of the accident. All the different crash investigation, again, when we start a crash investigation, the first task that we cover is the gathering of all the data. When we talk about car and we want to understand the car response, we have clearly in FIA Championship different level of devices that are deployed in order to get the data. I will bring you to example, let's say, of the top categories. Talking about a WRC car, clearly we download and we investigate all the data coming from the log, because clearly give us an idea about the driver behavior or how the driver reacted prior and after the accident, and as well the GPS, in order to have really all the information in terms of the car trajectory. Then we have installed the ADR, so the accident data recorder. This one is an accelerometer that is mandatory in all the FIA Championship. Is installed as close as possible to the COG, and is basically recording with the acceleration of the car at 1 kilohertz of sampling, so at a quite high rate. And this one clearly is for us one of the main tools, because it really gives us a perfect picture about the response of the car in terms of deceleration along the 3 axes. Then in in WRC as well, we have deployed what we call the high-speed camera. It is a camera that is installed in the dashboard and is pointing at the driver. As well, we talk about an high frequency, an high sampling device, and allow us to understand what the driver experienced within the cockpit during an accident. F1 is similar. So we rely on GPS and car data for understanding the dynamic of the car during the accident. We have an accident data recorder to understand the deceleration experienced by the car. We have an high-speed camera that in single seat, specifically in F1, is installed in the halo and is pointing at the driver. And only in F1, we have the earplugs accelerometer. So the earplugs accelerometer basically do 2 accelerometers that are molded in a silicon and let's say installed in the ears of the driver, and allow us to gather as well an additional important information that is basically the deceleration experience by the driver's head during an impact. So this one the different device that we rely on when we talk about data and we talk about all the parts related to the assessment of the car response. Then clearly we have additional accident data recorded that we have developed in the previous year, and that are clearly targeting not the, let's say, top FIA championship. So one of them is the ADR that is covered by the FIA standard 8872 of 2018. Is a device that doesn't require an FA log. What it requires is just the energy supply. And in terms of function, it basically works as one of the devices previously discussed and implemented in F1 and in WRC. It is an high-frequency device able to record the deceleration of the car during an accident. What you have in the blue on the right is the idea. Quite true. Most of you know this device. It is something that we have developed mainly in order to have a small and cost-effective device. It doesn't require power supply. It runs with an internal battery. In terms of lifespan, we talk about 2 years of service, and it is easy to install because it requires just to be bonded to the car, and it should come as well with an adhesive tape with it. And this one allows as well to get the deceleration that the vehicle experiences during a crash. On the operativity as well is quite easy. Once a crash is when the car experiences a crash, there is a QR code with a mobile application. So once the QR code is scanned, it downloads automatically the data that can be, let's say, analyzed and shared. So this one, let's say, to sum up a bit this session, this one are all the data that we get when we want to perform an accident investigation, and we want to understand what happened to the car. So car data clearly coming from the log. In parallel, we have an ADR, so an accident data recorder, in order to understand what the car experienced during the crash in terms of deceleration. Then as well, we rely a lot on video footage. So what can be CCTV when we talk about circuit, what can be media or host video when we mainly talk about closed event. But as well, when we talk about video, we rely as well a lot, for example, on social. We will discuss after about the accident of Le Mille, and I have a perfect example in order to bring to you. Then, for competitor safety equipment, circuit closed road and operation, here the data are, let's say, depends in relation to the type of accident. Clearly, what we analyze following an accident is the status of the device. So we collect picture of the part. That can be an helmet, as reported. When we talk about circuit or closed road, clearly we go to the scene. The three pictures, just for your information, are related to the accident of Grosjean. So clearly, if we talk about circuit and we see that a barrier that can be a tire or techno or a triple guardrail, referring to this example. Clearly, we ask people on track to go at the scene and get as much information as possible. So picture, but as well measure. And when it's required, especially for competitor safety equipment, we try to collect the part in Geneva for additional information. So to conclude, it is quite clear that when we talk about crash investigation, we talk about the processing of a quite complete and sometimes complex amount of data, because clearly every assessment that is performed within the safety department, but as well and consequentially every deliverables that comes out from the different groups, all of them are data driven. There is no deliverables that is, let's say, validated by what we can define the point of view or subjective assumption. Everything is always assessed based on data. We must every time understand what is the problematic. We need to be able to quantify it in order to start a project, be sure of what we have deployed, how much is going to be an improvement for safety, and always be able to quantify what is this improvement before the final deployment. So moving to the two case studies that I would like to present you. So the first one is the accident of Zhu driving the Alfa Romeo was in Silverstone in 2022. I think most of you may remember this accident. So start of the race, Zhu proceeding on the left side of the track. Russell experiencing a contact with Tsunoda, losing control, impacting with the front, with the left wheel, the rear wheel of Zhu, that caused clearly the launch of the car. Car upside down, impact with the primary and secondary roll of a structure, car sliding in the runoff area, getting launched basically in the gravel bath, airborne with an initial contact with the time barrier, final contact with the debris fence, and car resting between debris fence and impact and tire barriers. Another video of the accident from the onboard of Russell, where you can see the contact that basically caused the launch of the car and the loss of control. High-speed camera. So this the data that we get out from the HSC. And I will play it again. No? And this one as well allow us, in this specific case, clearly, to observe, first of all, the dynamic of the driver during the accident. But as well, he allowed it to spot the failure of the primary infrastructure that car 23 experienced in this specific case. So, video, high-speed camera, we have an idea of what happened, how we proceed, where we need to perform a crash investigation. So what we do, as I said, we collect all the data and we start breaking down what happened during the accident. The first breakdown, maybe the most important, is the definition of the loss of control. Why it is important? Because in most of the cases that we investigate, a lot of effort is put in understanding how to avoid the loss of control. So when we see, for example, this specific accident, clearly there are a lot of aspects that, on a safety point of view, worked incredibly well. The driver came out of the car without reporting any type of injury. So it was already a great success. But as well, we have seen, and we will discuss about it later, that there were a lot of safety devices, especially as I said before, the loop, that actually didn't work. Anyway, clearly, in this specific accident, we worked mainly on understanding how to modify the technical regulation, so design requirement and performance requirement of the part, in order to avoid the failure. But as well, we spend the same amount of time in try to understand how to avoid the loss of control. Because clearly, the loss of control in each single accident is always, from our side, a safety aspect that needs to be considered. So coming back to this accident, we did break down in 4 different phases. So critical phase 1, loss of control and launch of the car caused by the wheel-to-wheel contact. Second phase, the car following the launch, landing on the roll-up structure and sliding upside down in the runoff area and launching. Critical phase 3 was the car getting airborne, impacting with the barriers and following with the debris fence, settling to 0. And the critical phase 4 was the medical and rescue response. This one is a phase that we always assess, especially in this specific case, where anyway the access to the driver was quite complicated due to the fact that the car was stuck between fence and tire barriers, and due to the fact that the car was upside down. So going a bit more in detail for each single phase, critical phase 1, here a bit highlighted with the footage of the different cars. We have Tsunoda, that was, let's say, the trigger of this accident, that with the front right tire engaged the left rear of Russell, that clearly was forced to turn on the left and engaged with the rear tire wheel of Zhu. This one clearly caused the launch of the car. Second phase is the one that basically was the most concerning for us. Not the most concerning, but the one on which we worked more in relation to this accident, and was the car impacting with the ground and experiencing the failure of the loop. This is something that you can see, we could spot from the high-speed camera. I will play the video again. And clearly was something that we raised straight after the accident as a serious safety concern. And following this accident, we triggered straight a dedicated project in full collaboration with the Formula One manufacturers in order to come out with a technical regulation update and raise the performance of the structure and upgrade the design requirement of the loop. In the second phase, we experienced another let's say, potential a dynamic that we would prefer to avoid, so a car launching and flying and not being able to engage the first line of protection. So impacting with the top phase of the tire barrier and experiencing the main impact and deceleration with the debris fence. And the last phase, as I said, was on the operational side, where clearly the access to the driver was quite difficult from the rescue, and as well was quite deeply investigated internally in order to mitigate the risk of such condition to happen again. So following the breakdown, clearly we start really working on data. So what you have here is the deceleration experienced by the car. And so this one, how the ADR data look like. What we do usually is we follow the breakdown of the accident. So we have the phase one following the launch. What you can see that was putting again all the data together. So deceleration of the car data, footage from the off-speed onboard, but as well the high-speed camera. We were able to, I would say, perfectly reconstruct what happened in such a complicated accident at the end. So what we can see as, let's say, relevant phases or sub-phases of this part of the accident is when the car, following the launch, engaged with the initial engagement with rollbar. Then, as you can see, after 30 milliseconds is when the roll loop failed, and what we could spot from the ADR was basically the deceleration that the car experienced at the failure. Following the failure, clearly we have the big spike in terms of deceleration. In this specific case, clearly predominantly along Z, and that is basically the result of the car landing on the secondary impact structure, so on the halo. Following the first phase, we have the car launching in the airborne, so we can clearly see when the car starts pivoting on its left side in descent. generating a lateral acceleration of over 10G. The initial impact at the top of the barrier that was predominantly along Y and of approximately 10G. The final impact at the debris fence that was with the car basically flat upside down at the level of the floor with a vertical deceleration of approximately 11G. And the car at the end landing between fence and tire barriers and resting to V0. So what I've tried to give you in this case study are basically an example of how we usually operate when we talk about crash investigation. So to summarize, we have an accident and we collect everything that we think can be helpful for better understanding what happened on track in terms of accident, in terms of car response, in terms of driver equipment, circuit infrastructure, and operational point of view. When we have all this package information, we start post-processing them. And this one clearly is one of the most tough part of the task, because clearly we need to align, as presented in this slide, all the different information and basically synchronize everything in order to understand in each single phase of the accident what happened. And this one clearly at the end allow to quantify basically what happened. Just to give you a clear picture, as still referring to this accident, here we did spot, let's say, a lot of positive aspect. As I said, the driver was able to come out basically without any type of injury after a quite severe accident. But clearly, we did observe different points that required additional assessment and triggered research project in order to be improved. As I said, the launch in single-seater car is a problematic that we are aware of. Is mainly driven by wheels being uncovered, as we all know. The failure of the roll loop was clearly I would say, the main safety concern. Following the accident investigation, we were able to basically engage with the F1 teams with a full package of data, not just related to the accident, but as well related to which was the deceleration and the force experienced by the roll loop at failure. So we were able to trigger a project with teams with a full package of data and not just, video or any sort of interpretation. Following the engagement with the teams, clearly we did put together a complete project that led to complete redefinition of the roll loop. The modification of the technical regulation came out 8 months after this accident. And in 2026, this structure anyway is gonna be even improved more following what we have measured and experienced and seen in terms of data on track. So this is what we do in terms of crash investigation when we talk about the circuit top category. Okay, so with a package of information that is quite complete. Moving to another top category, this time on closed road, I will refer to the accident of Neville 2019 during the WRC Chile event. This is another quite famous and spectacular accident. So Neville coming out from a crest, wide, impacting with the front left wheel, and basically losing control of the car and triggering a quite long and severe rollover. Now, here you can already see the difference between F1, so a circuit, and a closed road event. When we talk about WRC and we talk about footage, we cannot always rely on CCTV because clearly we talk about a complete different environment. So the level of data that we manage usually are completely different. So for this specific accident, we had this footage, and another one that for us was really important was the video that was taken by one of the spectators, and that is basically taking the dynamic of the accident from the other side. But as well, what we recorded was more on the operational point of view. So the spectator approaching the car following the accident, trying to take out the driver. So let's say covering all that operational aspect that usually is performed by the rescue team. Here you have the footage of the high-speed camera. Clearly, when we talk about accident in WRC and in F1, we always look at something that is completely different. What you can see in this accident is that the high-speed camera failed in one of the rollover. So the camera is installed on a dedicated bracket in the dashboard. So what we can see is that started recording was well fitted, pointing at the two drivers, but in the middle of the rollover dynamics, it failed, and we could not basically observe the response of the driver in the second half of the rollover phase. I will not break down the accident as I did for F1. I would like to show you the accident analyzed in a different view. So what you see here is basically a program that one of the tools that we have developed internally within the research group is basically we called it data playback tool, and it allows us basically to synchronize any sort of data and any sort of video, whatever is the sampling of the video, the sampling of the data, and basically allow us to, let's say, put all the information that we have in a single project and synchronize it. So this is in slow motion how high-speed camera and the two different footage get aligned with the ADR data. So white, red, and blue are basically longitudinal, transversal, and vertical deceleration experienced by the car. In this specific case, we are talking about a quite long accident. So is approximately 7 seconds of rollover. When we talk about accident in circuit, we talk about milliseconds in terms of impact. So when we talk about especially closed road event, we always work with an amount of data that is most of the time larger. So I will play it again. So what we have here is basically loss of control, where you can see an high lateral deceleration. We have the first rollover, impact with the windscreen reinforcement, second impact with the rear of the car. Then here we have a long airborne that resulted in the car landing on the right side. As you can see, we have a spike in terms of longitudinal deceleration of approximately 25 G. Impact with the front of the car, and then car that start decelerating, losing kinematic energy and resting to zero. So this one, again, all the data that have been assessed in order to really understand what happened on in this specific accident, and really understand what basically the roll cage experienced. So out of this accident, we mainly triggered and came out with two different projects. The first one was related to the upgrade of the technical regulation in respect to the fixation of the high-speed camera, because clearly, looking at the video, we were able to spot when the support failed. So coming back to the ADR data, we were able to understand the level of forces that the car experienced in the specific moment. We were able to come back to the manufacturers, start a discussion from there, and define the new, let's say, strengths of the part. So basically, we came out with different design requirements that were anyway able to withstand such a level of deceleration. The second one was mainly related to the definition of basically the current Rally 1 tubular frame specification. So at that time, 2019, we were working on the definition of design performance requirement of the tubular frame. Following this accident, we did decide to take some of the sources experienced by the car as reference load cases for the new tubular frame. So again, it allowed us, this crash investigation allowed us to really understand what worked, what didn't work in this specific accident, but as well leverage on something that happened on track, take out data from that specific condition, and basically use it for future projects in order to be sure that what we are going to deploy in terms of next technical regulation is going to be anyway able to withstand what the current cars are basically experiencing. Going a bit longer, I'm gonna, sorry for that, I'm gonna cover the last part, maybe the most important, WADB and support from the ASN. So just to give you a bit an idea, in the last 5 years, as I previously mentioned, we did cover approximately 750 crash investigations. We did run more than 50 research projects that lead to the definition of new safety standards, and more than 100 safety regulation updates. As well, we did try to spread as much as possible what we consider our experience and the best practice, coming out with more than 50 safety bulletins and 13 new safety guidelines. I hope I made you understand or make clear how much the crash investigation can be important for us, okay? Clearly, I did present you 2 cases that are related to FIA championship, but most of our crash investigation are focused and are performed on international and national series, because clearly, statistically, the number of competition, number of FIA competition are, I would say, negligible compared to all the motorsport that is running around the world. So this is why your support is really fundamental to us. When we perform, and this is something that I would like to make it clear, when we perform an accident investigation, our target is not to find who we should blame. Our target is always to, first of all, understand what happened. Second and final target, understand how we can avoid it. So your support in providing information following the accident is fundamental and essential for us and for improving safety in motorsport worldwide. So WADB, most of you know it, is the online portal where all the information following an accident can be loaded. Info and guidelines can be downloaded from the website. When an accident report should be triggered, clearly in three main conditions: fatal accident and serious accident. Clearly are the straightforward one, but as well in insignificant accident. So how we define a significant accident? I did try to list them in the slide. So when the ADR trigger, so cross the well-defined threshold, in case an ADR is installed, but as well in case of driver reporting concussion, spinal injury, injury in general, let's say. Or if, let's say, required by a race director, technical delegate, or medical delegate. Anyway, I would like to add something. Please share data from your side, even out of these bullet points. If you observe or you think that it is a significant accident, so something that, in your opinion, should have not happened, we really appreciate and support anyway in you sharing additional information with us and potentially discuss about what happened if it was really something that it should not have happened, and start from there in triggering a new project and investigate how to avoid it. Submission process reported in the slide. So we have, you can find all the information in the guideline that you can download from the website. This presentation anyway is gonna be shared by Sela following the webinar, so you can find all the procedure and information in it. I did run a bit over my time, so sorry for that. Ella, I would come back to you.
Thank you very much, Marco.
I can stop sharing.
Thank you very much, Marco. Now let's move on to the final part of today's webinar, the Q&A. We have received a few questions here. The first one is from DMSB, from Misha Effort. So Marco, I guess this question is for you. How you monitor the accidents? Do you have any monitoring system, or do you use the cases of the WADB? How does the FIA find out about accidents, especially international and national level?
Is a super interesting question. So out of the information that clearly we receive from you, and out clearly of the FIA Championship, where we have a complete control of them, we really work on web, on Facebook, Instagram, social network, magazine. We have consultants that are their main task is basically spot accident around the world. So I would say is one of the most complicated part of the accident investigation, because clearly we cannot cover all the motorsport world. So we need really to put a lot of effort in try to dig into sport magazine around the world. But again, social, all the type of social media, in order to try to see if a significant accident occurred, and then start from there, investigate the data that we have, that most of the time are social media video, and if we think is really significant, try to engage with promoter, club, team, in order to try to engage with them, discuss about the accident, and potentially get the information.
Thank you, Marco. We have another question, this time from FMU Uganda. Enoch Leroy Olinga would like to know, how does one access the IDR device? Is it only exclusively owned by the FIA?
This one I have Luis Goish, that is part of the safety department, and I would be happy to bring him, because he's our idea expert on a technological and operational point of view. So I would invite Luis to cover this point. Please, Luis.
Hello, I hope everyone can hear me. And thank you so much for the kind words, Marco. It's an interesting question as well. From the beginning, we always had the idea, we developed the IDR as a tool for the ASNs. So every ASN can come on board of this project. And each and every ASN will have their own database with their own access and several levels to access all the data, all the accidents that happen in their categories. So as Marco explained very briefly, the system is based in 3 pillars. So you have the devices in your cars, then you have your officials with the app, and then when there's an accident, then the reports will go to the database that will be available to you. This database, if the ASNs that are on board of the project, if they want to share the data with the FIA, we will also have access to it. But to resume my answer directly, is open to any ASN that wants to come on board. If you prefer, you can send me directly an email or to Marco, and then we'll take a discussion more in depth. Thank you.
Thank you, Luis. We have another question. I think this gentleman is from Bangladesh, Syed Ararul Hussain. Is there a time limit for the reporting of accidents? Is it better to submit the information late than not submit it at all? This is for you, Marco.
Yeah, quite easy answer. Absolutely, better late than at all. Absolutely. I mean, again, I will cover another point just to give you an idea about my usual Monday afternoon. we take a seat all together. We pass through all the accident of the weekend, but once we close them, we come back to what still needs to be assessed from accident of previous weekend. And consequentially, always better to receive information even late rather than do not receive them, because clearly, if we don't receive anything after a bit of time, we will just let's say we will not be able anymore, even if spotted, to understand what happened in a specific crash. So again, better late than never.
Thank you, Marco. Another question from Piotr. What about accidents in karting?
This is a good question. Accident in karting clearly have been assessed most of the time in absence of data, because clearly kart does not have logger, does not have sensor that allow us to understand the forces and deceleration experienced by the kart and the driver. So what we have done so far was to basically rely on the video of the accident and then come back to the team and drivers when we needed to get additional information. Anyway, in this year, in Academy Trophy competition, we did deploy for the first time the IDR on cars. So we started a process basically in order to start collecting vehicle data as well in karting. So we did deploy it in Portimao first event, then we went to Valencia, and as well in Cremona, so the last event that took place last week. All the academy cars are installed with the IDR. Target clearly from our side is to start collecting data about what a kart vehicle experienced during an impact and start building up a background, basically, of vehicle data as well in karting. Anyway, so far was just footage for the future. So in light of this problematic, that footage anyway most of the time are not enough for understanding the dynamic of the accident, we deploy the ADR in order in the future to better understand the karting behavior, and using data able to come out with a package of technical regulation, sporting regulation, and competitor equipment in karting that can be better than the current one.
Thank you, Marco. This was our last question for today's webinar. If you or Luis have something to add, I'll let you speak. And if not, and if there are no more questions, I guess we will close this webinar for today. So thank you very much, Marco, for that insightful and informative presentation on data-driven safety improvement. I myself have learned a lot personally, and you have provided us with valuable knowledge and practical perspectives on how data can drive meaningful change in motorsport safety. Also, thank you to everyone who joined us today. We truly appreciate your time and participation. Before we close, a quick reminder, in the recording of the session and the presentation slide will be available on FIA Networks in the coming days. So be on the lookout for that. And we also invite you to join us for the second session of the October Safety Series, which will take place on October 8th, so next Wednesday. And this time the topic will be safety equipment homologation process. It's an essential element of motorsport safety, and you won't want to miss it, I guess. Until then, stay safe, and thank you once again for being with us today. I hope you enjoyed. Thank you. Bye.